Okay, I just wanted to go through this quickly to highlight a couple things with this algorithm with the insertion sort. So first of all, you'll see that I set some indices. I use I and J. No, I could have also put the I, declared the I inside the for loop. A little more conventional, but since I'm using an I and a J, I just did it there. Initialize count to 0. Then each time I go through the loop, I start at 1. So my second position, I create a temp person, which is the element that I'm looking to compare. And my main part of the loop is I'm going to go through that each time and compare my temp person with the one immediately to the left of the index. So I'm going to keep seeing where it gets inserted all the way down until I found it, or I run into the end at j greater than 0. That's why j has to be greater than 0. When I go in here, each time I'm doing that, I'm making comparisons, so I increment my count. This part here, I'm going to set the index, the element at index j, to what was previously at j minus 1. Basically, this is just the swap with the neighbor step. And I decrement to keep working my way to the left. And then finally, I have found exactly where it goes. The temp person will go, and I put it in to that index j position. Remember, the count basically counted the number of times I went through that while loop, which is going to keep iterating through the for loop and will be counted and will be finally returned here at the end. So let's take another quick look at the shuffle. This one, with shuffle, there's a lot of different ways you can do this. What I elected to do is I basically shuffled a number of times equal to the size of the array. There's nothing particularly scientific about that or precise, as to whether if you shuffle through one time for each or two times for each, but it should give it a good chance of mixing up. Basically, I picked a number. So let's say if my array was of size 10, then 10 times I go through and I'm going to pick a random index. And each time I get that random index, as I do in this step, I'm going to take whatever's at that random index. Now remember, when I call a remove, the remove will take it out of the array list, but it also will return whatever was previously in that array list. So I can just call the remove and the add, and that effectively takes it out of the current random position and puts it to the end. So again, if it's size 10, 10 times I'm going to go through, randomly pick something and move it to the end. So that should be enough to substantially shake everything up so that it gets into a randomized order. Like I said, there are many, many different ways you could do this, and I'm not even claiming this is the best or most efficient way, but just giving you the idea. And probably the step that's the most important is this guy right here, where you want to look at how you're going to actually remove and put something back into the array. Some of you use the shuffle method of collections, which is okay, but that's kind of outside of the AP subset. So it's a good idea to have a different way to do something like that. And you probably, in reality, wouldn't be asked to do that on the AP exam. But you should be you should have a good enough understanding of array list that you could do something like this if you needed to. So anyway, hope that helps. Hopes that gives a little more clarity. And hope it all makes sense. Thank you.